Hi guys, this is section 5.2, the examples from this section. I just finished recording this and then the audio dropped about a minute or two in, so this is my second time through, so let's go for it. Find endpoints on a standard normal distribution with a given property and sketch the area. So remember from the screencast of the lesson, what we're trying to do is find the value that has 0.95 in the middle. So that's a matter of using our function. So we're looking for what we're going to call a z star and a minus z star. So I'm going to go over to the RStudio Cloud setup that I've got for chapter 5, and we're just going to run through a few examples. We'll clear out some of this old stuff. So xcnorm is the command that's going to be in the center, the center probability. So if we put in 0.95, by default we have mean of 0 and standard deviation of 1. So we get the values 1.96 and negative 1.96, centered at 0, of course. So that's the endpoints are negative 1.96 to 1.96, and those are our values of z star and negative z star. Let's continue for 0.8 in the middle. So we just change that to be 0.8. So not surprisingly, it's narrower. It's down to negative 1.28 and positive 1.28. So the same picture, but 0.8 in the middle. So we'll have negative 1.28 to 1.28, and that interval would have 0.8 in the middle. Okay. Now you try it for 0.9, and I'll pause. Okay, I'm hoping that you gave that a try. And let's see, we have 0.9 in the middle. And the magic numbers in this case are going to be negative 1.645 to positive 1.645. Somewhere in between these two, and that makes sense since the probability is between those two. So let's see, so we have 0.9, right? And so that's our negative 1.645, and 1.645 rounded to 3 decimal places. Those are very famous levels on the 90 and the 95, not so much the 80%. All right, so let's go ahead and do confidence intervals in 3 ways to make the connections that we wanted to see for this section. And I'm going to do this in R. A survey conducted by the Pew Foundation found that 536 of 908 Twitter users say they use Twitter to get news. We wish to find a 95% confidence interval for the proportion. So the proportion is p hat equal to 536 over 908, and that turns out to be 0.59. You can see that if you don't believe me. 536 over 908, so we get 0.590 to 3 decimal places. So what is the sample statistic? 0.590. We want to get a 95% confidence interval. We'll use percentiles on a bootstrap to find that. So let's go for it. Over here in R, we're going to do bootstrap dot p hat, and we're going to do 2,000 of these, say, and we'll do R flip. And what was our sample size? It was 908, and the prob, let's see, it was prob is equal to 0.59. And if you put these in order, it shouldn't matter. You shouldn't need the prob there, but let's take a look and see what we got. So we'll do tilde prop, data equals, and remember we have to use the one that we just created. What did I forget to do there? Oh, I didn't have a comma. All right, so, and then it's centered at 0.59, which is what we want. And now in this case, we wanted to use the percentiles from a bootstrap, so we'll use CData of that, and I can just do some shorthand here and use that, and then we're going to use by default, we'll get the 95% interval. So I guess we can specify it precisely. P equals 0.95, and we get this interval 0.556 to 0.623. All right, in this case, 0.556 to 0.623. Your answers will vary since this is from a simulation, but they should be pretty close. All right, next part, we can model the bootstrap distribution with a normal distribution with mean equal to the sample statistic, which was 0.59, and standard deviation equal to the standard error of the bootstrap. So let's go get the standard error of the bootstrap. We can just use the histogram format, and again I'm using the up arrow to do that. So there we go. 0.017 is what I get to 3 decimal places. 0.017. And then we're going to use that to get the confidence interval. So stat plus or minus z star times the standard error. So 0.59 plus or minus my 1.96 from up above. All right. Times the 0.017, and let's see, for the endpoints of that we're going to get equals 0.59 minus 1.96 times 0.017, so 0.557. And the other endpoint is 0.59 plus 1.96 times 0.017, we get 0.623. And what number is exactly in the middle of those two? The 0.59, right? It's symmetric around that. So quite close to what we got for the percentile interval, which makes sense because this is going to be very close to a normal distribution with the simulation in RFlip. And a large sample size, right? The sample is 900, so the central limit theorem that we learned about last section will apply. So what's z star for a 95% confidence interval? All right, z star is 1.96. Oh, I'm sorry, what have I done? Use the normal distribution to find the 95% confidence interval. I'm sorry. What's the mistake I made? This was what we're intending to do here. The procedure here was we wanted to use the bootstrap interval. Okay, I was getting ahead of myself. So we want something that's centered at 0.59, so we're going to use the percentiles, or use the normal distribution with mean of 0.59 and standard deviation of 0.017, and get the confidence interval that way by finding the middle 95%. So let's take a look. That will be the XC norm function that we're using before. We're going to have 0.95 in the middle with the mean equal to 0.59 and the standard deviation equal to 0.017, as we got from there. So we get the interval 0.557 to 0.623, which is exactly what we get here, and that's the point. So 0.557 to 0.623, and that's coming from the normal. I got ahead of myself here, so this is what we're using for this next part. All right, so sorry about that. But the idea is that the three answers are very close. These two are identical because it's just rescaling the normal distribution. We change the mean and standard deviation to be standard normal, and so the three answers are very close. So these are essentially equivalent methods. Let's take a look at another example. See if I can avoid a mess up here, but who knows. So this is on BMI for a large sample of adults. So this is X bar. And we are told that the standard error for this estimate is 0.009. So that's our SE. So if we use the normal distribution to find a 99% confidence interval, what's Z star? So let's see, did we get that value yet? I don't think we have. So we're going to use that. So the Z star value is going to correspond to 0.99 in the middle. I know it should be further out, but that gives the idea. So that's going to be, well, let's go find out what it is. So we use XC norm, once again, 0.99 in the middle. But now we're just getting the multiplier from the standard normal, as we did before. So we get the 2.576 is what that rounds to. So 2.576. And then there's a negative of it, negative 2.576. So our Z star value is just 2.576. So our confidence interval is our statistic, which is 27.655, plus or minus our Z star, 2.576, times the standard error, 0.009. Okay, so let's see what we have here. This is 27.65, right? So that's a stat, plus or minus Z star SE. Okay, so let's do the calculation. I'll just do that in R, and I can show you something there too. 27.655 plus, now something I sometimes use is just to save space. The C of -1 is a way to do the plus or minus idea. 2.576 times the 0.009, and then we get both endpoints at once. So 27.63, and the upper endpoint is 27.68. So quite a narrow endpoint. So it was a large sample. That's why the standard error is so small. So we're 99% confident that the true mean BMI of adults is between these two numbers. So the population mean of U.S. adults. And that's as of the time the study was carried out. We don't have a sample size, or we don't have the year in which it was carried out. Okay, let me just check my numbers there, make sure I'm giving you the correct value for that, and it looks like it is. Alright, so example 4, obesity in America, exercise versus non-exercisers. See the difference in mean BMI between non-exercisers who said, this is apparently self-reported survey data, and exercisers who have exercised in the last 30 days versus those who haven't. So non minus exercise. So we were wondering how much higher is it for those that don't exercise. The standard error given here. So we use the normal distribution to find a 90% interval. So we found that piece up above, and we found that Z star was 1.645. You can check right up here, we found it, 1.645. All right, so find and interpret the interval. So once again, we're doing the stat, plus or minus the same idea, Z star, okay, times SE. So 1.915 plus or minus 1.645 times the standard error, which was kindly donated to us. Otherwise, we would have had to get it using the bootstrap. So we'll try that trick one more time. So 1.915 plus or minus, and then we're doing the 90%, 1.645, and the standard error becomes 0.016. And we get this interval, 1.889 to 1.941. So that's 1.889 to 1.941. And we're 90% confident that the mean BMI for exercisers is between 1.9 or 1.89 and 1.94. Points higher than it is for non-exercisers in the population. Okay? So BMI is an index, so it's 1.89 to 1.94 higher for exercisers than non-exercisers in the population. Okay? All right, then finally this is a self-quiz, so you should test yourself. And then I'll go ahead and pause and then give you the answer. Okay, so let's review. Hopefully you've given this a try. In a recent survey of 1,000 U.S. adults conducted in January 2013, 57% said they dine out at least once per week. Who would have guessed that this would be a public health question? The standard error for this estimate is 0.016, so that's our SE. Normal distribution defined in 95% confidence interval. Interpret your answer. So here's the interval calculation, statistic plus or minus a z star SE. Here's the interval. We're 95% confident that the proportion of all U.S. adjust should be adults. Who would say they dine out at least once per week is between 0.539 and 0.601. And I was thinking about this. I think through my lifetime, probably hasn't varied as much as that statistics varied in the last couple months. Thinking about things like the Iraq War, when we were involved there, after 9/11, I think people might have been afraid to go to public places for a while, but nothing compared to the change in that proportion over the last couple months. So it would be interesting to see how much this has varied. I suppose if you consider takeout as dine out, that might be a complication. But anyway, hopefully this is getting to be pretty straightforward for you now as you see how the algorithm works out. Take care. I'll see you in the investigation.